I'm Andy Morgan, and we do air source heat pumps.
So what's so different about your heat pumps?
Basically, there's no CO2 emissions. They run off air. They're a lot cheaper than gas, oil, traditional boilers. They take over. You can run them in parallel with traditional boilers. The technology is relatively new to this country. We're way behind Europe. I mean, 20,000 of this particular product have been sold worldwide. The company's been going 20 years, but it's only now that we feel totally comfortable with the technology and the reliability, etc. So hence we spent a couple of years researching different products, ground source, wood burning, etc., and felt, this was the best product on the market. They act like an air conditioner in reverse. If you can imagine a fridge, it's exactly that effect in reverse. So basically the air is dragged in through the unit and then it's compressed to a huge extent in a process similar to a bicycle pump. If you can imagine pumping up a bike and the end of the pump gets very hot, and that's what the compressor does. That then is transferred into a heat exchanger, which dissipates the heat into the water. The water heats up, hence it heats up your radiators and hot water, and then it dissipates through the system and comes back, and the process is repeated. If you look at the unit, it's basically a boiler, and this is where people get confused in that they think, well, how on earth does this work? But in effect it is a boiler, which just replaces traditional oil or gas.
So it's very simple. You just come into the house, take out the old boiler and put this one in.
Yes, I mean, if you're swapping over, they're electrically it's very, very simple. Plumbing-wise, if it's a combination boiler, it's a little bit more complicated, but it's nothing that we can't sort out. If it's a traditional oil boiler, it is literally flow and return. You just cut the pipes and pop the new boiler in. In the winter, at 0 degrees, between 0 and 5 degrees, it runs at about 2.9 COP, which means you put 1 kilowatt in and you get nearly 3 kilowatts out. At 15 to 18 degrees, you're looking at 3.5 kilowatts. So a kilowatt in, 3.5 kilowatts out. So even in the winter, you're still getting free energy, which is one of the great aspects of it. If it's up to like 25 degrees, you can probably get 4 kilowatts out, which means you get the 3 kilowatts free. I think a lot of people are sceptical because it's new technology. But what we are finding is builders, developers are becoming more aware of the green aspect, and therefore they're crying out to use them because they have to achieve certain green efficiency with their new builds, and this helps with it. And once people see them running and we can convince them that they do actually work, they really are the future. One of the things we find people are interested in is the huge effect it has with carbon emissions. Basically, we all know electricity does create carbon emissions, but we feel that the limited amount of extra electricity that you need, the carbon emissions are nil once this unit starts. The electricity has been generated anyway, and I mean, as everybody's aware, there's so much concern these days with global warming, etc. We think this is the way forward because it's going to save thousands of tons of carbon emissions, which we feel is quite important. We do 3 or 4 different versions. We've got the air to water, which does heating and hot water in a domestic house. We do another version of that which also does air conditioning, so you've got heating, air conditioning and hot water. We also do swimming pool pumps, which are selling very well because they're so much cheaper to run than oil and gas. And we also do single room applications, which we call our air-to-air range, which is heating and cooling for conservatories or an office or a shed where there's difficulty getting water supply there. So we're covering most angles. We do single phase, 3-phase units, so we can cater for industrial premises, commercial premises, and also we can bank up the single phase units. So if you've got a large domestic house, it's unlikely that you'll have three-phase electricity in there. So therefore what we can do is put 2 or 3 units together and increase the capacity, and you can either run all 3 units, or you can dedicate one to heating, which you can then turn off in the summer, and have 2 running at hot water. So we think we've covered all angles. For us to run a 3-bedroom house would be roughly £2,500, including VAT, to buy the unit. Although we realise this is more than you'd pay for a combination boiler. There's no servicing, there's no maintenance. You have a full 2-year warranty, as you would do with a traditional boiler. The CO2 emissions speak for themselves, there aren't any. We've got some more technology being introduced to the units as we speak. The initial cost is more, but as I say, there's no servicing, no maintenance. It's completely clean. The unit is positioned outside. It can go up to 50 metres away from the house. The decibel levels we've got down to about 31, which is equivalent to a whisper at 2 or 3 metres. So we think we've covered all angles, and it's just convincing people that this does work.